Hello students, I am myself Mrs.N.Sivasankari, Assistant Professor in EEE Department, and the topic we are going to see is machine learning. We all know that the machine learning is becoming popular, and it comes under the artificial intelligence, and it is an approach to achieve the AI through the system so that it can learn from the experience in order to find out the patterns that are present in the data. Usually it involves just like teaching a computer to recognize the patterns. For example, rather than we are programming it using certain rules. So every data consists of certain patterns, and our job is to find out the hidden patterns that are present inside the data. And this ML, that is the machine learning, is all about creating the algorithms, and these algorithms are able to learn these complex functions or patterns that is being present in the data, and it has to predict, right, and it has to make predictions based on the patterns that it has learned from the data, and it comes under the category of one of the forms of narrow artificial intelligence. And the main thing is that the machine learning usually it learns through examples. You are training these algorithms with several examples, and based on that it will learn. That is, it predicts the stuff that is essential, and we call it to be an intelligent one, since it takes some form or certain form of data in order to train. Usually how to train the system. And then what it learns is that it certain patterns or attributes or functions that's being present in this data, so that which it has not been familiar with, and it makes a best guess of that what you're giving for training. And based on this knowledge that is being gained through training, so this learns itself from the data. So this machine learning system, it can be reused to learn any future objects, so that we no need to rewrite the code again and again. So in that way we can say that this is being very powerful. Then we have to choose how we have to choose the data in order to train this machine learning systems. That's one of this crucial part in machine learning, and we will see this one by one. For example, here we are taking the fruit that is orange. So how we identify this is an orange? So it has, obviously it has the color. The color is orange, and based on it has some weight. So in our example, you have seen this weight is almost, it is 340 grams. So it is orange in color, and it weighs about 340 grams. So these are the attributes of things that is related to this data. So here the data, so here it is an object. The object is obviously it is a fruit, orange fruit. And here what are the attributes we are taking? Attributes are nothing but the features. So here what we are taking is the color of the fruit as well as the weight. So these are the two features we have taken. Then you see here you are plotting the attributes for two fruits. Here you are comparing apple as well as orange. You see the orange is orange in color, and this apple fruit, so it's red and green mixed. Some apple will be purely red in color, and some we have some mixed shades of both the green as well as red. So here what are the two attributes we are taking is the color as well as the weight. Okay. So here it is a two-dimensional plot. So here you are having a line. Okay, so this line separates that is one fruit from that of the other. So here you see an yellow line, the fruit above, that is the color orange in color. So you can conclude that it is orange, and you have that reddish, or a greenish red, so we consider it to be the apple. So we here that is the number of darts. So here the number of darts specifies the weight. Okay. So here this is in the before here, this is the right way here of choosing that is the in machine learning. Since you are initially training that system, you have to choose that is the choice of the correct feature or attribute is very essential. So that means that is the improvement of the output largely depends upon the right choice of this features here. So you see, as I told earlier, if you are choosing a correct or useful input feature, means it has a very great impact on this output or the quality of this your machine learning system. Suppose some features, if you are choosing it wrongly, okay, for else here what we have chosen previously, what we have chosen is that what are the attributes we have seen, this weight as well as the color. So it is based upon the weight and color. It is the system is able to completely categorize. Okay, it is able to select the right one, which one is orange and which one is apple. Here the plotting is done. Here you are what is the features we are selecting here is the number of seeds as well as the how ripe, okay, how the ripeness. So here you see how it is able to, so okay, bad features, ripeness as well as the seed count, so it do not match exactly. So in order to figure out whether it is an apple or it is an orange, so it's now the job becomes tough. So it's unable to separate, okay, whether it is or find out whether it is an apple or orange based on the attribute, that is the number of seeds as well as the ripeness. So here the choice we have made here is the bad one. So it's not the right choice. Okay. So it's the here, but here we have chosen the right choice. That is why the ML system is able to find out which one is apple and which one is orange. That is, it learns well. Okay. So in this here, if you here the system will become, so it is somewhat it is fuzzy. Okay. So it's not able to correctly sort of it. Now, so here already we have seen in the fruit example, here the dimensions what we are using is 2 dimensions. Okay. Sometimes we may also need 3 more dimensions, so 2 in order to figure out it. So here in the example what we have seen is here it is making use of 3 dimensions. So here you are making use of a separate plane. So here this plane is used to divide the 2 set of data that is being shown here. That's the cat, dog. Okay. So most of the problems in real time it's maybe very complex, and it is not only limited to this either 2D or 3D, and it is you can have it in the range of even the 20 dimensions or even millions of cases if you are going for image based problems. Here since in an image each and every pixel you are having a definite detail. So in that case it is very difficult to visualize. Okay. The thing since it's very higher than the 3D dimensions. So here and also this machine learning principles is either what may be the case, it is the same. Then if you are adding more dimensions, what is the use? So it greatly helps in order to separate out the data points. So here the machine learning system, so it is able to split the data into several groups, and this we call it as grouping it, the data. Here it's a classification problem. So this is the one here you are figuring out. You see, they are figuring out based on some features. Okay, that is the cat and dog. So, and one more thing, if you are having too many dimensions, means that may also lead to overfitting. What do you mean overfitting in the sense? Here, the system usually it learns from the example data. So it's very perfectly it learn if it does that means. If you are giving any new data, so here the ML it is not familiar with that data, so it's new. So in that case, so it may not able to generalize well if you are giving the new data. So this is mainly due to this overfitting problem. This is one of the drawback. Then another one more challenge which we face in this ML training is this that is you have to find out you should have this enough and biased training data. So that is and it should be consist of all the features. So okay, so in the format that you are presenting it to the ML system. Okay, then suppose if you want to recognize or if you are giving an input image to the system and you want to recognize that cat, okay, so you are giving so many images, and from that what is the desired output you need is that you need the system has to identify that it is a cat. Okay, so for that you need to train the system. For that you may need 10,000 example images, okay, for training the system. Then only the system is able to find out whether you are giving so many images, so many cat images in so many colors, poses and etc. Even then it is able to recognize that it should be a cat. Means what you have to do, you have to train it using 10,000 example images of this cat. Okay, so here in the data it should not be, obviously it should not always be images. So here you can make use of certain multiple features. Okay, that is the sound, some other body heat sensor recordings, so many other attributes of can also you can have if you are having a table having those things that can also be fed as an for training the system. Then one more thing, initially say you are teaching or you are making an ML system it has to study about animals, and initially you are training a system using the two animals. One is say dog and another one is chicken. So here what are the attributes you are taking is the legs, the number of legs, as well as the color, as well as the weight. Okay, these three attributes you are taking, and initially you are trying the system. And these three attributes of dog and chicken alone, not other animals. Okay, so now the system is learning. Now in front of the system, you are presenting the image of a cow. You may think that the cow has also 4 legs, black, and maybe you see it's almost 200 kilogram. Means what the system will do is that it will predict this as a dog and not as a cow, because it has not, because you are not given the image of the cow so far. So what it does that, what is the closest match? You see, it is a chicken. No, it has 2 legs, but here it has 4 legs. And okay, so based on that some color may be orange or okay, based on what is the closest match here is weight is also it's more. So based on the 4 legs, so it will predict this as a dog. It won't predict this as a cow since it has not aware. So initially you are not trained the system using the image of a cow. Okay, so that's the way the ML goes on. Then how you are training this ML systems. So here that is the learning state. What type of states? Most probably you will be having this supervised, unsupervised, as well as the reinforcement learning. That is the three way you can train the system. First we will say upon this supervised learning. So here initially in supervised learning, so here what you are doing is you are providing the training data to the ML system that is already labeled data. Here you are giving the labeled data in order to train this ML system. So what are the things you see here? You are taking two features or attributes. Okay, so you see, for example, if the color is red and weight is 200 grams, then what is the label? You are labeling it to be apple. Okay, so if the color is red and weight is 200 grams, then it is an apple. So this is the, and if the color is orange and the weight is 300 grams, then what's the label you are giving? It is an orange. Okay, so if the color is green and the weight is 150 grams, then also it is an apple. So likewise here, based on some certain features or attributes, you are deciding. Previously it is the no that okay, if these two matches, it's an apple. If if the color is orange and the weight is 300, it matches. Like the weight is already all the data you are labeled. So what it will do if you are giving, okay, so from fruit, so it will check it with the previous labels. Okay, for or else not like that. If it is red in color and 200 grams means what it will do? Okay, from that table, so it will tell, okay, this will predict it will be an apple. Okay, so it is the likewise the system is able to based on this labeled data, it can be able to predict the future and see inputs. Okay, so this is the supervised learning. So in unsupervised learning, so here you are not having any labeled data set. Instead you are having an unlabeled data set. So here you see in the graphs you are having three bunch of points. Okay, that is each one representing three different data or things. So what it does is that the machine initially it has to find based on some other features. What it has to do is it has to group it into the three different clusters, and you have to categorize it. The machine itself, it has to do it. So here the number of clusters is it may not be known. Okay, how many clusters it has to form, that it is not known to the system. So it has to, that is the system has to make a guess. Okay, but the clusters, here you have seen it is well defined three clusters, but in real time it may not be this much clear. Okay, so the guess may also goes wrong. Then reinforcement learning, it is just like trial and error method. Okay, so if you have tried in maths and all, we will be seeing, we will solve the problems for equations by using the trial and error. Okay, so you try some methods. If this output is correct, then what it means, you will be rewarded, or you will get some +2 marks. So if it goes wrong, means what you got, it will be marks will be detected like that. Okay, for each and every good move, okay, each and every good move, what you are doing is rewarded, you will get a reward or else positive point or like that. So for a bad move, or if any loss happens, means that then you will be getting punished, you will get punishment, and in the sense it may also be treated as a negative reward. So what happens is that over time goes on, so the system will study. So if more positive outcomes it gets, means what it will do, it to maximize the reward, and for the bad moves, so it will be so it will get punishment or negative reward, means so the next time it won't repeat it. Okay, so in this way, so for each and every time, so it learns through these experiences. So what it will do is, by doing this sum correctly, okay, this method you are getting, this one is right, means we will try on based on that method. Likewise it goes on. So it will here the machine will learn, or it will just like us. Okay, which is like human-like performance. So it goes on, moves on means it will learns from better. That is, it will learn from each and every positive. So what happens? The time grows means what it happens. It will expertise in that and it will perform even better than us. So that's the way. That is the main forced learning. We are forcing through trial and method, and we are forcing the positive outcomes by putting a reward, and the bad or negative outcome we are punishing it. So we are forcing the system to do better. Then coming to how does all this work algorithms that work, so that we have to see. So there are many ways in which ML system is able to try and learn the patterns in order to classify the data we are giving to it, and we'll see some examples. Okay. Example 1, you probably have seen in graphs. Okay, and if you know the x value, then you will find out if you put some values to x plus y is equal to 5. If you know the x value, if you are putting x for x, you are putting it 0, means what is the y. Okay, so the y value will also be 0. For example, if you are putting this x value as 1, means what you will get, y will be getting it as 3. Likewise, substituting in the equation, 2x plus y is equal to 5, means what you will be getting. You are putting substituting the value of x to be 1, then you will be getting this y to be 5 minus 2, it will be getting 3. Likewise, so these are all the things we are doing in our high schools. So here we are drawing a line of best fit. So it's a very simple example of this ML. So here you can predict if you are given x, what will be the value of y, as I told you earlier. So this comes under this form of regression problems. Okay. Then here, so here you are using a line to here you are having the 2 clusters. Okay, you are having 2 clusters, and here you are making use of a line to divide these 2 clusters. Okay, you see the line is probably which will belong to the red class, it being separated from the blue class. You see inside this red class you will be having this blue, so it's an outlier. Okay, so here we have used a straight line, so it will be more complex one. Okay, all the times we are not able to correctly separate it. So instead of this straight line, so here your ML can also be used to classify the 2 clusters of points by the sampling this, that is the nearest one, based on the nearest known points, that we can call it as the k nearest neighbor. So here you are having a color background, you see, so it predicts the points it has not seen before. So here the observation you see at the right, so blue, you are able to see blue, and it will be, and the 3 closest points, okay, nearer to it is also the blue one. So based on the nearer one, it will find out. So then what are all the outputs that we get from this machine learning? So here see, that is the regression problems mostly will be here it is the system is able to predict the numerical, that is the output is the numerical value. Suppose the classification problems in the sense, for example, you are given so many images of an animal, it's the cat, dog, you have to find out. Okay, so that is you are getting only one answer. Okay, either it may be a cat or dog or human, this based on the labels. You are classifying the inputs. Yes, this belongs to the class cat, this belongs to the class dog, and this belongs to the category human. So like in this way we are classifying, so based on the labels. So the clustering is this grouping. So similar products are grouped together. Okay, so that's the way we are classifying it. So which one belongs to the major, like that way. Then sequence prediction. In the mathematics we are able to fill the series or sequence what comes next. Okay, so if this is like this, then what will be the next? So in this way it's the sequence production. So in this 4 way, these are the 4 common type of output which we expect from this machine learning system. Then you see here, it's the continuous output. So as we have seen, so many continuous decimal numbers, that is. So you get some numerical output here. Okay, for example, if you are having this orange paste 200 gram and its radius is 4.2 inch, the output is 4.2, and this is the way it is tries to predict. So the linear regression. Okay, here you are using a straight line. Okay, that is the line of fit, a straight line, the data. So it will predicts for some value of y, what is the, suppose you are having some value of y, for that given value of y, what is the output or the input. Okay, so in this way you are doing. As I told earlier, the classification problems. So here, what are the inputs you are giving? That is the color, hair color, pass. So you are having this cat or dog, you have to find out. Okay, so here based on, you see here inside the picture you are having, that is the color, you are having soft pass and it is having whiskers. So most probably based on these features, what it will get, it is not a dog, it will be a cat. Okay, so this in this way is one of the classification problem. Then probability. Okay, probability. So here here the output of this machine learning is almost, it is in the case of this decimal number between 0 and 1. So what is the desired output? Okay, so here you see here so many bricks, white, yellow, not yellow, green, red color bricks are in the jar. So if you are getting this output is 9, means the probability, how much probability of getting this, any one of this, that is the 54.3% or it is 75.1%. So okay, what is the probability of the output? Okay, so that's the way it's and then using this, what is the use of this output? Okay, so here only what you have to do is, once you get an output, so it's whether it's for this regression, probability or classification problem, so we have to do what is the use of this gain knowledge. Okay, so if you are getting this 80% you are sure, means you can feed that for further analysis. If you are means 75% only you are sure, means you have to wait and you have to train it more for better results. Then the types of what are the types of available ML algorithms, that and how they are working, that we will see. So here you have this regression type of algorithms. Okay, and here it's mainly concerned with this iterative modeling. That is the modeling, that is the, what is the relationship between these variables. Some relationship is usually exists between these variables, and you are studying that and you are measuring the error. Usually how much error, for suppose you are having some actual values and you have the predicted values, means what is the difference between this actual and the predicted one. So that's the difference we will be able to calculate the error. So how much minimum error you are getting, so that much the algorithm works well. Okay, so here the straight lines of best fit. So these are all the examples for linear regression. Then instance based algorithms. So here on regression algorithm, square regression and ordinary least square regression. So that's an example for this regression algorithms. Then for instance based. So here you are having, it is a decision based problem. Okay, decision based problem. So here you are initially building up a database which is having some example data and comparing it with the new data of the database. Here you are making use of some similarities that may be present between the data. Okay, so which one is having the best match? So based on that you are making the prediction. For this purpose we are going for this instant based methods. So just you are training it using this example data, and how based on this already stored these instances and how much is the similarity between these instances, means the prediction is done correctly. So one of this example is this nearest neighbor method. A decision tree. So here the decision tree method, here you are having based on here in each node you are getting this, you are putting a decision whether it is green or yellow, right? Okay, then if it is green, what is the weight? If it is 100 or 200 grams. Okay, if it is green and if it is 150 gram, analyze, then it is applied to each node. You are having this making use of the decisions. So how many on the whole, okay, how many decisions, so it has passed out. So based on that you are getting this output. Okay, so it may be either a classification or regression problems. So the naive Bayes, so here you make use of this Bayesian methods, and that explicitly here you are applying this Bayesian theorem for mostly for classification and regression problems. So here as an example what we can say is, if you want to find out this whether the mail is a spam, okay, whether so what are the features? So it's a spam mail means based on the what type of words, okay, if it contains some unnecessary or unethical words means, so it comes into the category of spam. So in this way, so we can sort out. So that is the naive Bayes. Then clustering, as we seen earlier, so here it describes the problem based on some classification. So here they are organized by the modeling approach, as well as whether it can make use of some whatever it may be centroid based methods or hierarchically it can do it. So all these methods, they are mainly concerned in using this data structures in order to best how it can best organize the data, so into some maximum similarity, so that we are able to categorize or classify it. Okay, so K means K-medians we can use. Then association rules. So association ruling methods. So it is also some extract ruling methods that is able to based, so it is some association or relation between these variables. Okay, so these rules can discover what is important and what is useful and what are the useful associations. If you are having this large number of data sets, we may go for this type of algorithms, a prior. So ANN, as we all know, we are familiar with that. It just functions like this biological neuron which is present in our human brain. So here also you have a large class of pattern matching techniques, and they can be used both for regression as well as the classification problems, and so many subfields are under this type. The basic model of this is the multi-layer perceptron or BM, that is a radial basis network. Then the back propagation, so this comes under this basic artificial neural networks, and nowadays we are going for this deep learning networks. So here if you are having a huge or large data sets and your problem is much more complex means and you are in that case you are having only a very little amount of data means you can go for this deep learning. So this convolutional neural network as well as this yes, multi-layer, just not like simple perceptron, your multi-layer perceptron models also comes under this ML. Then dimensionality reduction. Okay, so here it is just like the string method. So here what it does is that what is the inherent structure, it exploits that inherent structure that is being present in the data. So here it is one of the unsupervised, it is not a supervised one, and it better summarizes that. That is, if you are giving even with the less amount of information, it is able to it can give a better summary of the data or describe it. And mainly it is used to visualize the data mainly for a simplification of the data that can be used in supervised learning. So this is can be adopted both for this classification and regression. Usually principal component analysis, that is in the data pre-processing process, we can make use of this. Okay, we can using this PCA as well as this then ensemble methods. So here the method, it is one of this models that is composed of multiple weaker models, means you can independently you can train it, and this prediction here is somewhat, it is a combined prediction. Okay, based on this combined prediction, it will give this overall prediction. Okay, so here the effort is that you have determined how the learners and what way we can combine them. So it's very powerful. So nowadays it's becoming popular. That is the XG boosting. So that comes under ensemble learning and XG boost. So far we have seen this machine learning the overview. So custom models Okay, we have this TensorFlow, that is machine learning engine. Okay, the TensorFlow we are popularly using this one of the libraries for learning this AI and machine learning using Python. Mostly we're using this TensorFlow as well as Keras. So inside the TensorFlow library we are having this Keras module and we are making use of it. Then these are the custom models and some retrainable models, in the sense you are having AutoML, vision and translation is NLP usually. Okay, then AutoML, it is the natural languages. Okay, that is then pre-trained models. Pre-trained means already have some that models we are having vision API, that is the vision application programmer, interface, and speech API, jobs, NLP, that is natural language API, translation and video intelligence API. So in this way we can fruitfully make use of the machine learning for so much problems that is available in real time. So we have seen a good overview of this machine learning algorithms and how we are able to use it for our real time problems we have seen. Thank you, students.